In this demo, we'll look at the Cloudant REST API, and we'll use a Chrome browser extension called Postman that allows us to exercise that REST API. And we'll walk you through a couple of typical calls, like creating a document, retrieving a document, updating a document, and calling a secondary index. But first we'll start off by going into Bluemix and creating an application that has an instance of the Cloudant NoSQL database service bound to it. So first we'll log into Bluemix. Next, I'll create the app. We'll use a boilerplate to create the app. And we'll select the boilerplate that contains a Node.js runtime with a Cloudant DB service instance. Let's give the app a name. Our app is started, so let's go ahead and take a look at it. In particular, we want to take a look at the credentials for the Cloudant service that's bound to this app. In particular, we want to take a note of the username, password, and the host URL for this instance of Cloudant. Next, we'll go to the developer portal at cloudant.com so we can get some sample data. Note that it prompts us for credentials. We'll use the credentials that we noted earlier in Bluemix. Once we've authenticated, we're able to replicate a sample database called AnimalDB that contains documents with information from Wikipedia about 10 different animals. With our database set up and sample data in hand, we can now turn our attentions to using the Postman extension to call the Cloudant API against the sample database and the sample data. So first we'll set up our URL, which we got from the credentials we saved from our Cloudant instance in Bluemix. We need the host name. Next, we append the name of the database, AnimalDB. And finally, our first call will be to get a summary of all the documents in the database, so we use the appropriate suffix for that. Next, we have to provide our database authentication information, and we can do this by using basic authentication. So we select this in the tool and provide our user ID and password that we noted earlier. We'd also like to let the tool know that the data coming back will be JSON formatted. So we set an HTTP header called content type, and we set that to application/JSON. With these two values set, we're ready to go. So we can go ahead and call our first API call. And as you can see, we got back 11 documents total. The first one was a secondary index that contains a number of views, and then we had 10 documents representing 10 different animals. Note that this only returns a summary of those documents, not all the fields. In particular, it returns the ID, and it also returns the revision number, which gets updated every time the document is updated. Next, let's look at getting a single document from the database. In order to do that, we can reuse the setup we did before. We have to modify the URL by including the ID of the document that we want. Everything else stays the same, the header, the content type. Then we can make the request. And we get back the single document. Note that in this case, rather than a summary, we get all the fields of the document. Now let's look at doing an update of a document. So it's very similar to retrieving a get document, but instead of using a get, we use a put, again with the document's ID. And we provide the updated document. So now we're just copying the original Zebra document and fixing it up a bit. In particular, for an update using put, we don't need the ID, we just need the rev, so we can get rid of that. And then, of course, we need the actual update. So here we're going to go ahead and change the minimum weight from the original Zebra document. Change it from 175 to 176, then we send our request. And we get back an indication that everything is okay. Note that we get back a new revision number. And note that the revision number starts with an integer which indicates the number of times the document has been updated. So previously our revision number had a 3, now it starts with a 4 because this is the 4th time we've updated it. Now let's do a get to see if our update was successful by retrieving the same document again and checking that the minimum weight has indeed been changed from 175 to 176. And it looks like it has, so our update was indeed successful. Now let's look at creating a new document. For this, we'll use the put operation, and we'll create a new document called wildebeest. And we'll simply reuse a lot of the zebra data, even though zebras and wildebeest are very different. So we do a put, provide the ID, we provide the data, and since we're copying the zebra data, we'll get rid of the ID, the zebra ID, because this is for wildebeest, and there is no rev required because this is a new document. So let's get rid of that. And now when we submit this operation, we should get a new document called with an ID of wildebeest that contains all of the data from the zebra document. There you have it. We have a new document, and you can see our rev starts with 1 because this is the first time we've saved it. And we can use a get to retrieve it, and there you see we get an entire document with all the fields that we borrowed from Zebra and the new ID of wildebeest. Now let's look at the delete operation. For delete, we need the rev of the document as well as its ID. And this is done via the HTTP delete operation. So we already have the ID. We'll just delete the document we just created. And let's add a parameter to include the rev. With the HTTP delete operation, this is done via a parameter called rev. So we just expand the URL that already has the ID to include the rev. And we include the value we copied. And then when we submit the operation, we get the thumbs up saying that the delete was successful. Note if we try to delete again, we get an error saying not found. And similarly, if we try to do a get operation on this same record, we should also get an error. So let's go ahead and try that. We'll reuse the delete URL. For a get, we don't need the rev number, so we'll get rid of that. Then we'll send the request, and as expected, we get an error saying the document is no longer there. Now let's look at the secondary indexes. Secondary indexes are defined in design documents, and these design documents can be fetched in their entirety from the database. In AnimalDB, there's a single design document called Views 101, and we can get that using the get operation by specifying the database name followed by the keyword design followed by the name of the design document, which again is Views 101. So as you can see, when we send that get operation, we get back all the contents of the Views 101 design document. And if we format it as JSON in the tool, you can see that it has a number of views, each one having a map and in some cases a reduce function. We're interested in the one called Latin_name, and what this does is it returns the Latin name and the length of that Latin name in characters for all the documents that actually have a Latin name field. So let's go ahead and actually see what comes back from this specific view. We can extend the URL to add the keyword _view and then the name of the view, which in our again is Latin_name. So we'll add that to the URL and go ahead and submit the request. And as you can see, we get back 5 documents. These are the 5 documents in the database that had a Latin name field. Note that we don't get back the entire document, we just get back the fields that are returned by the map function in this particular view. If you need to return the entire document when you're actually calling a view, then there is a parameter on the view URL that you can use called include_docs. And if you set that parameter to true, then when you issue the command, the view will return the normal view contents as well as the entire document. So let's take a look at that. Let's format the return values. And as you can see, we have the same values as before, but now we have an additional field for each document called doc, and that contains the entire document. So this is useful in cases where you need the view to filter out some documents, but then when you get the data back, you need several fields in the document itself as well to process. Now let's take a look at Cloudant Query. As you recall, Cloudant Query provides a convenient mechanism for querying the Cloudant database in the style of SQL, or for those of you that are used to Mongo, in the Mongo style of issuing queries that are much like the where clauses of an SQL statement. So the first thing we'll do is actually create an index. And the API endpoint for creating indexes is _index. And we need a post operation. And we'll define an index. And in this case, we're defining an index on one field, the diet field, which is set to values like carnivore, omnivore, herbivore, and so on. And we'll give it a name my first index, and the type is JSON. As you recall, there are both JSON and text indexes. So with that set up, we can go ahead and execute this HTTP operation, and we get back an indication that our index was created. So now let's issue a query against the index. The API endpoint for issuing queries is _find. And like creating an index, this is a post operation. And in the body of the post, we actually need a selector. So in this case, we're using a selector that sets diet to carnivore. So this should return all the documents in the animal database that have this field set to carnivore. So let's go ahead and execute this. And as you can see, we have some results. Let's scroll down and format it for JSON. And here are results. We have 2 of the documents in the database that have this field set to carnivore. So that's the end of our demo. Hopefully you've learned the basics of using the Cloudant API. We talked about the basic CRUD operations, creating, retrieving, updating, and deleting documents. We talked about using secondary indexes. And then finally, we talked about creating and querying using Cloudant Query.